So the next topic we will talk about is power series. Okay, power series method. As per usual, we will talk about why we introduced this method. What is the motivation about this power series method? Okay, so the motivation. A lot of computational program is using power series because that is easier to program, and the base of the power series is polynomial. Okay, so a lot of computing and engineering would not happen without power series. So for example, what kind of programming we use power series as a base? We talk about finite element method. That is one of the approximations will use power series. For example, FEM, which represents finite element method. So this method we talked about before, it's solved for complex multiphysics and complex geometry method. And usually a big domain, the whole domain will subdivide into a small domain. And during the small domain, they use power series such as polynomials to fit inside the small domain to fit for the physics. And if that is close to the true solution, then it's ensemble to the whole domain. So finite element method will use power series as one of the big base of their solution set. And power series is very useful. Power series are useful. There are several points why power series are useful. So the first point is because that is essentially polynomials. So it's essential polynomial. And because that is the essential polynomial, so it's very easy to be programmed and it's very easy to work with. So it's usually good for solving differentials, limitations, integrals. It's easier to work with. And that will be useful for solving differentials and limits and integral. And the thing is, for the differentials, for example, we talk about linear ODEs, right? We talk about constant coefficients. We talk about Euler-Peirce equations. The one we haven't touched is the linear ODEs with variable coefficients, and that will be solved by power series. So one of the example we have for the differential is the linear ODE with variable coefficient. Okay. And for example, if we have exponential functions that can also be presented as power series. For example, e to the x will be equals to from m equals to 0 until to the infinite number, the x to the m divided by m factorial. That is represented by power series as well. So this is one type of the power series. Another properties for power series are useful. So the property for the power series, why it's useful? Because when you do the program, you can just use sum for representing the power series. And if you add more terms, that will be closer to the true solutions. So add more will be closer to the true solution. And you can think about this, add more will be closer to the true solution. In the programming, it's kind of like a for loop or while loop. And when you do loop in the program, it's very easy to deal with. Okay. And one of the examples for physics which use power series is the harmonic oscillator. Okay. It's quantum harmonic oscillator. So you have this potential well, you have basically the core electrons start from 1s to s to p, and you can go to 3D, etc. Those quantum levels are solved by using power series. Okay, this En will be equal to n plus 1/2 h mu. Okay. So these equations were essentially solved by power series. That's why at the beginning we said power series are useful. Without it, many problems couldn't be solvable. And it's very easy to be programmed. It's easy to work with. That's why power series are important for computing and engineering perspective. And you will see several examples we will list later how we can use power series to solve our ODEs. Okay. And the next part, we will go to the definition of the power series and how we can program it, how we can test whether this power series will be converging to the end or not using programming. Okay.